condition. Check for the optimality condition. And that is find the net, find the net evolution, uh, the delta z, j's, and verify delta j is greater than or equal to 0 for all case 1. Case 1, if all d's suffix j greater than or equal to 0 and xb greater than or equal to 0, then the current solution is an optimal solution. So case 2, suppose. What is the case 2? If all delta j greater than or equal to 0 and at least one of xb less than or equal to 0, then the current solution is not an optimal solution. Uh, in this case, go to step 5. Case 3. If these exists any delta j less than 0 uh, for some j, then the method fails. So step 5. So rules to check the feasibility conditions. Feasibility conditions. First one, leaving variable, outgoing variable. The leaving variable is the basic variables corresponding to the most negative value of xb, say xi. So second one, entering variables, incoming variables. So the ratio between delta j that equal to zj minus cj, row and key row are corresponding. So compute theta equal to maximum delta j equal to zj minus cj whole divided by uh, aij. So aij is less than 0. Aij is less than 0. Now we consider the ratio with a negative decision, negative denominator only. So the entering variable is the as the non-basic variables corresponding to the maximum ratio theta. If there is no such a ratio with a negative denominator present, uh, then the problem has no feasible solution. So next, step 6. What is the step 6? The procedure. The procedure. The procedure for simplex method is applied and repeated until either an optimal solution uh, is obtained or non-existence of feasible solution is indicated. Indicated. Difference between simplex method and dual simplex method. Uh, in basic regular simplex method, we start the procedure with the BPS. Uh, the BPS means basic feasible solution. BFS, basic feasible solution, which is generally not optimal. Recall this, and we work towards the optimal solution. But in the dual simplex method, we start with a basic feasible solution (BFS), which is optimal, and we work towards feasibility. The second important uh, difference is that in regular simplex method, first we compute compute for entering variable, then decide that outgoing variable. While in dual simplex method, uh, we first determine outgoing variable and then compute for incoming variable is basis. Okay. So since the dual simplex method deals with the primal problem as if it is being applied simultaneously to its dual, and as the criteria used for incoming and outgoing variables are uh, for dual problem. This method is termed as dual simplex method. This is known as dual simplex method, most important for 20 marks question theory. So, illustrative example. First one, solve the LPP means linear programming problem by dual simplex method. Dual simplex method. What is minimize z equal to 3x1 plus x2 subject to constraints. X1 plus x2 is greater than or equal to 1. So, so 2x1 plus 3x2 greater than or equal to 2. X1 comma x2 greater than or equal to 0. Solution. The standard form of LPP is maximum z dash equal to minus 3x1 minus x2 minus x2. Uh, Next, minus x1 minus x2 less than or equal to 1. Minus 2x1 minus 3x2 less than or equal to minus. Here x1 comma x2 greater than or equal to 0. Adding slack variables x1 comma x2, we get minus x1 comma minus x2 plus s1 equal to minus 1 minus 2x1 minus 3x2 plus s2 equal to minus 2 and x1 x2 s1 s2 greater than or equal to 0. So dual simplex table 1. huh? Suppose cj means cost variables or minus 3 minus 4 0 0. huh? So next, second one is BV means basic variables. Basic variables CB, XB. Uh, CB, XB means X1, X2, S1, S2. S1, S2 are slack variables. Here, S1, S2. Basic variable S1, S2. CB, cost basic variable 0 0. XB equal to minus 1, minus 1, minus 1, minus 1, minus 1, 0, minus 2, minus 2, minus 3, pivot 0, 1. That is outgoing variable. Uh, so delta J means Zj minus Cj. Zj minus Cj. 3, 1, 0, 0. So 1. So minimum is here outgoing variable. Incoming variable is most negative. We have to search for most negative. Uh, Minimum incoming minus 3. Here pivot. Pivot are also known as key element. Pivot are key element, same thing. So here basic solution. So x1 equal to 0, x2 equal to 0, s1 equal to, so s1 equal to minus 1, s2 equal to minus 2 is the feasible solution, but it is optimal. Optimal. Now let's proceed for further uh, interaction. uh, Iterations. Iteration xb equal to minimum of xb1 comma x xb1 comma x2. So here minimum of minus 1 minus 2 is minus 2. So here x2, here we have r equal to 2. Here the vector s2 leaves from the basis. From the basis also delta k by x2k equal to maximum of delta 1 by x21 comma delta 2 by x22 for x21 less than 0 comma x22 less than 0. So maximum of 3 by 0 2 comma 1 by minus 3 that equal to minus 1 by 3 that equal to delta 2 by x22. Here k equal to 2. So hence the vector x2 enters into the basis. Therefore, therefore pivot is minus 3. Now the modified simplex table is shown below. So dual simplex table 2. And it's iteration 1 or iteration 2. Iteration 1. Huh? So basic variable. basic variable CB, XB. So X1, X2, uh, S1, X2. So here, basic variables S1, S2. Uh, Cost basic variable is 0, minus 1. Uh, XB variable minus 1 by 3, 2 by 3. That is minus 1 by 3 is to 1. That equal to minus 1 by 3. Uh, so minus 1, 2 by 3, 2 by 3, 1, 0, 1 by 3. 1, 0, 1 by 3. Next, the delta j zj minus cj, 2 by 3, 0, 0, 1 by 3. Incoming variable, delta j equal to cb xb minus c1, that is 0, minus 1, minus 1 by 3, 2 by 3, plus 3 equal to 7 by 3. Uh, so delta j equal to CBXA minus CA, that is 0, comma 1, minus 1 by 3, comma minus 1 by 3, minus 0 equal to 1 by 3. So we observe that the basic solution is uh, infeasible, but it is optimal. Optimal. So iteration 2. Iteration 2 is XB equal to minimum of XB1. We have R equal to 1. We ignore XB2 as it is not negative. Now the vector S1 is uh, recovered. Let's complete. Now the entering vector corresponding to R equal to 1. So since delta k by xk, xrk, uh, x delta k by x lk, that equal to maximum of delta 1 by x11, comma delta 4 by x14, that equal to maximum of 7 by 3 minus 1 by 3, 1 by 3 minus 1 by 3, that equal to minus 1 by minus 1. So delta 4 by x14. So here we have k equal to 0. Since S2 has to enter into the basis, the pivot at this stage is minus 1 by 3. Uh, the modified simplex table is shown below. A modified simplex table. Here, basic variable S2, X2. Cost basic value 0, minus 1. Cj, XB, 1, 1. Minus 3, X1, 1, 1. Minus 1, X2, 0, 1. 0, S1, minus 3, minus 1. 0, S2, 1, 0. So delta J means Zj minus Cj. 2, 0, 1, 0. So here delta J equal to CBX1 minus C1. Uh, that means 2. Uh, delta 3 equal to CBX3 minus C3. That equal to 0, comma minus 1, minus 3 minus 1, minus 0. That equal to 1. So we solution, observe that the solution obtained at this stage is x1 equal to 0, x2 equal to 1, s1 equal to 0, s2 equal to 1, which is feasible and it is also optimal. Therefore, max z equal to 1. The solution of the dual problem can be obtained from the last table of the primal solution, as the values of delta j corresponding to slack variables of the primal, that is omega 1 equal to 1, omega 2 equal to 2. So advantage of duality and dual simplex method. What are the advantages we have to discuss about? Advantages. Advantages of advantages of dual simplex table. What is the advantages of a duality and a dual simplex method? What is in an LPP means linear programming problem. If the dual of a primal has less number of constraints, then it will be advantageous advantageous to solve the dual of the LPP. Dual simplex method saves us dual simplex method dual simplex method saves us from a regular laborious process of simplex method, as it does not does not need any surplus or artificial variables. Surplus and artificial variables. Next, dual simplex method can be used for those LPP which have the infeasible initial solution, but is optimal. Dual simplex method can be used in problems of problems of economics, engineering, and management. Management. The dual variables provide important important economic interpretation of the final solution of the given LPP. LPP means linear programming problem. These are the advantages, duality, and simplex method. Hmm. So check your progress. Problem is there. What is that? Model answers. Hmm. Next, page number 112. Check your progress. Model answer. So first one, the standard form of LPP means linear programming problem is maximize maximize z equal to minus 2x1 minus 0x2 minus x3 subject to minus x1 minus x2 plus x3 less than or equal to 5. Minus x1 plus 2x2 minus 4x3 less than or equal to minus 8. Where x1, x2, x3 greater than or equal to 0. 0. Adding slack variables s1, s2, we get max z equal to minus 2x1 minus 0x2 minus x3 subject to minus x1 minus x2 plus x3 plus s1 equal to minus 5. So minus x1 minus 2x2 plus 4x3 plus s2 equal to minus 8. The feasible solution. Initial feasible solution. What is that? X1 equal to x2 equal to x3 equal to 0 and s1 equal to minus 5, s2 equal to minus 8, uh, which is infeasible uh, but optimal. But optimal. Here, iteration 1. What is the iteration here? XB uh, equal to minimum of xm by xm less than 0, that equal to minimum of minus 5 minus 8, minus 8, minus 8 here r equal to 2. Thus the variable s2 leaves the basis. So since delta k divided by delta rk, delta 2 by 2k max delta 1 by x21, comma delta 2 by x22, delta 3 by 23. So max 2 by minus 1. So 1 by minus 4, that equal to minus 1 by 4. Here k equal to 3. Thus x3 enters into the basis. Basis x3 is incoming variable and s3 is variable. Outgoing variable. Applying the simplex method and writing it in tabular form, we get. So BV means basic variable. S1, S3. CB means cost basic variable. 0 minus 1. Uh, XB, variables of basic variables. CJ. So minus 2, 0, minus 1, 0, 0. Here XB are the X1, X2, X3, S1, S2. So here S1, 0, minus 7, minus 5 by 4. Here minus 1 by 2. This is the pivot. How to find pivot? Minimum ratio and most negative incoming variable. So 0, 1, 2 by 3 outgoing variable. Here 0, 1 by 4, minus 1 by 2, 1, 0, minus 3 by 4. Here 1 by 2 incoming variable. Uh, incoming. Now the infeasibility has been removed. Removed. So we step into iteration 2. So iteration 2. Hmm? XB iteration 2 XBR equal to minimum of XBI by XBI less than 0, that equal to XB1 equal to minus 8, here R equal to 1 and K equal to 2. Therefore, X2 enters the basis. X2 is incoming variable and S1 is outgoing variable. Now applying simplex method, we obtain the uh, we obtain the modified simplex table as given below. Uh, basic variable x2 x3, cost variable 0 minus 1, cj minus 2 0 minus 1 0 0, cb cost basic variable 0 minus 1. So xb equal to 14 9, x1 1 by 2, 3 5 by 2, 3 by 2, 5 by 2, 3 by 2. 5 5 by 2, 3 by 2. 3 by 2. 1 0 minus 2 minus 1 by 2. Here 0, 1 by 2, 0, 1, minus 1, minus 1 by 2. Uh, so delta j equal to here zj minus cj. 1 by 2, 0, 0, O, 1 by 2. And z equal to 9 minus 9. Since all the basic variables are non-negative, we stop the iteration procedure. Thus the solution is x2 equal to 0, x2 equal to 14, x3 equal to 9, and z equal to minus 9, which is optimal. Uh, the dual of the LPP is minimum z that equal to 3y1 plus 5y2, subject to 2y1 plus 8y2 greater than or equal to 40, 3y1 plus 4y2 greater than or equal to 50, and y1, y2 greater than or equal to 0. Hmm? Okay, so model examination performed. So today what we discussed today, so unit 9, we discussed about unit 9 solution of a dual simplex method. A dual simplex method. So introduction. introduction. What the term duals refer to interchangeability of a particular pair of particular pair of terms. Uh, the concept of duality is very useful in linear programming problems uh, as they provide solutions to uh, changing industry and managerial decision making issues in linear programming duality. Duality implies that each LPP can be analyzed in different ways, yet have equivalent solutions. Equivalent solution. For example, the product mix problem. It is required to maximize the profit function or cost function. Profit function also known as cost function. Through it is the hmm, maximum the profit, uh, maximum the profit at the same time. It takes care of the minimal, the minimization of raw material. Another example is the diet problem. In this example, suppose it is required to provide a maximum nutrients uh, to the patient or client uh, who undergoes uh, weight weight reduction. The same LPP is viewed in another perspective as minimization of consumption of food items. That is maximization of profit function is associated with the opposite aspect of minimization of cost function. Minimization of cost function. So simplex method, procedure of a dual simplex method. Uh, what is the step one? If the given original LPP is a minimization, LPP is minimization type, it is to be converted into maximization type. Step 2. If there exists any greater than or equal to type of constraints, they are converted to less than or equal to type by multiplying with -1 throughout the inequality. So step 3. So express the LPP into standard form by introducing the slack variables. New obtain Now obtain the initial feasible solution. IBFS means initial feasible solution. So prepare initial simplex table. Step 4. Check for the optimality condition. Uh, for the net evolution delta j's and verify delta j is greater than or equal to 0 for all j case 1. If all delta j is greater than or equal to 0 and xb greater than or equal to 0, then the current solution is optimal solution. So case 2, if all delta j is greater than or equal to 0 and at least one of xb is less than or equal to 0, uh, then the current solution uh, is not an optimal solution. In this case, go to step 5. Case 3. If these exists any delta j less than 0 for some j, uh, then this method fails. Then this method is fails. So step 5, rule 2, check feasibility conditions. Uh, leave, leaving variables, outgoing variables. Uh, the leaving variables is the basic variables corresponding to the most regular negative, most negative value of x b, then xk. So next entering variable. Uh, Leaving variable is most negative. So entering variable means incoming variable. The ratio between delta j, zj minus cj, uh, zj minus cj row and by row are compared. So compute theta that equal to maximum delta j equal to zj minus cj by aj, aj less than 0. Note, we consider the ratio with a negative uh, denomination only. Uh, the entering variable is the non-basic variable corresponding to the maximum ratio theta. Is there is no such ratio with a negative denominator present, then the problem has no feasible solution. So, next, step 6. The procedure for the simplex method uh, is applied and repeated until either an optimal solution is obtained or non-existence of feasible solution uh, is included. So difference between simplex method and the dual simplex method. Uh, in basic regular simplex method, uh, we start the procedure with BFS, means solution, basic feasible solution, which is generally not optimal. Recall time this, and we work uh, towards the optimal solution. Put in the simplex method. Dual simplex method. We start with basic feasible solution, which is optimal, and we work uh, towards the feasibility. The second important difference in the is that in regular simplex method, first we compute first we compute for entering variable, then decide about outgoing variable. So which is a dual simplex method. Uh, we first determine outgoing variables and then compute for incoming variables uh, in basis since dual since the uh, the dual simplex method deals with the primal problem as if it is being applied simultaneously to its dual, and as the criteria used for incoming and outgoing variables are for the dual problem. Uh, this method is termed as dual simplex method. Dual simplex method is most important for 20 marks problems. Okay, theory. So page number 100, page number 108. Illustrative examples, most important. Solve the following LPP problem by dual simplex method. By dual simplex method. So this under advantages of duality and dual simplex method. Hmm? So advantages of duality and dual simplex method. Also we discussed, and today and check your progress model answer question also we discussed. So it is if we this unit is most important for theory 20 marks questions. Okay, so this was completed. This we discussed today, 9th unit. Okay, tomorrow we'll discuss about 10th unit, transportation and assignment problems. Okay, this unit is completed. So tomorrow we'll discuss another unit, unit 10. Okay. leaving.